Today we're going to be talking about ellipses. So if I take the equation of a circle, let's center it at the origin. Radius, let's say radius is 5. Okay, if I divide both sides by 25, then I get x squared over 25 plus y squared over 25 is equal to 1. This is another form of the equation of a circle that we don't really use, but it is handy to think about as I'm about to talk about ellipses. Okay? So this would be a circle centered at the origin, and we go 5 units in the x direction, 5 units in the y direction to sketch that circle, right? That is exactly how we sketch an ellipse, except for an ellipse, these numbers will not match. Okay? So you might have a squashed circle or an elongated circle, ellipse, okay? So it's an ellipse is a little bit like a squashed or elongated circle. Okay? Other than that, they're very similar to circles. So for this ellipse, I know it's an ellipse because these numbers are different and there's a plus. That makes it an ellipse. If this was a minus, this would be a hyperbola. We're going to do that tomorrow. So I'm going to go to the center. The center is at +2, +3. I'm going to go 4 units. It's always the square root of that. 4 units in the x direction. 1, 2, 3, 4. And 5 units in the y direction. And then we sketch our ellipse like that. Okay? This center would be -5, -3. 1, 2, 3, 4, 5. 1, 2, 3. I'm going to go 3 units in the x direction and 5 units in the y direction. Just like that. The center is at +6 and 0. I go 6 units in the x direction. 1, 2, 3, 4, 5, 6. If you have to go off the grid, just keep counting as you would. 6 units in the x direction and 3 units in the y direction. That would be that ellipse. Okay, with ellipses, because they're not circles, they don't have a constant radius, we have a major axis and a minor axis. The major axis is the longer distance, so this is the major axis, okay, of this ellipse. This would be the major axis. I'm going to do that in orange apparently. So this major axis would be right here. This major axis would be right here. And then the minor axis, let me get a different color. The minor axis would be the other one, the shorter one. So the length of the length would be, so the length of this minor axis would be 8, because I went 4 in each direction. Okay? So what is the length of the major axis in number 1? The major axis, to get the length of the major axis, we can, if we graphed it, we can just look and count how many there are. Clearly there are 10. But if I had not graphed it, I would go to that number and I would say I need to double the square root of the bigger number. That would give me 10. For the minor axis, I need to double the square root of the smaller number, so that would be 8. So in number 3, we have this equation, and they ask us what is the center. Well, the center is 6, -9. The major axis has length, okay? The major axis has length 2 times 10, or 20. The minor axis has length 2 times 8, or 16. Is the major axis in the x direction or the y direction? It is in the y direction, because it's under the y's. Okay, it's vertical. It has a vertical major axis. This one here has center 11, 0. The major axis has length. Which one is bigger? This one is bigger, so the major axis has length 2 times the square root of 81, so 18. The minor axis has length 2 times 7, so 14. And this time the major axis is in the x direction, because the larger number is under the x's. So this major axis is horizontal. Okay. Every ellipse has 2 foci. The 2 foci lie inside of the ellipse on the major axis. The sum of the lengths from the foci to any point on the ellipse is a constant. So this length plus this length is equal to this length plus this length, which is equal to this length plus this length. Okay? In fact, that is the definition of an ellipse. An ellipse is the set of all points in a plane, the sum of whose distances from 2 distinct fixed points, called foci, is constant. To find the foci for an ellipse, we use this equation. C squared is a squared plus b, minus b squared. Okay, that's how we find the foci. So for this ellipse, they ask us to find the foci. Foci is the plural of focus. So there's one focus, there are 2 foci. All right, so for this one, the larger number here is your a squared. The smaller number is your b squared. So c squared is a squared minus b squared for an ellipse. So here c squared will be 100 minus 64. C squared is 36. So c is 6. This is the distance from, that is the distance from a focus to the center. That is the distance from the focus to the center. A focus, either focus to the center. Okay? So on this above example, there's C here. I don't know if I have another color. I don't know if you can see this red. There's the center. That's the center, not to be confused with C. So this would be the length C. That is C, all right? This is also C, right there. That's that length from either focus to the center. Okay, so to find the points that are the foci, if it says find the foci, we need to find the points. I start with my center. The center is -3, +1 here. And we are going to add and subtract 6 from the bigger coordinate, so the y term in this case. So plus and minus 6, because the foci lie vertically. So the foci will be -3, 7, and -3, -5. Let's find the foci of this equation. So first I'm going to find c. So c squared is a squared minus b squared for an ellipse. I think of it this way. There's a plus here, you need a minus there when you're finding c. So c squared will be the bigger minus the smaller, so 49 minus 36, which means c squared is 7, and c is the square root of 7. That is the distance from the center to either focus. The center is the point 5, -8. I need to add and subtract square root of 7 from which coordinate? From the x coordinate, because the foci here, the foci lie horizontally this time. So the foci will be 5 plus and minus square root 7. You are welcome to write it like that. That describes two different points. Okay? If you prefer, you can write it as two separate points. Okay, let's graph this ellipse. Let's graph this ellipse. So this is not in standard form, so we need to get it in standard form by completing the square. I'm going to begin by grouping my x's together, leaving a space, and then I'm going to group my y's together, leave a space, move my 64 to the other side, -64. Okay, before you complete the square, you must get the x squared and the y squared coefficients to be 1. So I'm going to factor a 9 out of my x terms, and I'm going to factor a 4 out of my y terms. All I did was factor a 4 out of those two and a 9 out of these two. Now I'm going to go in and complete the square. Half of 4 squared. Half of 4 squared is 4. But really I am adding 36, because 9 times 4 is 36. So I need to add 36 to this other side. For the y's, half of 8 is 4, squared is 16. But really, I am adding 64. So I add 64 to the other side. Okay, this is going to be 9 times x plus 2 squared plus 4 times y minus 4 squared. And that is equal to 36. It's still not in standard form. I need to divide both sides by 36 because we have to get a 1. We have to get a 1 over here. This is going to give me x plus 2 squared divided by 4 plus y minus 4 squared divided by 9. And that is equal to 1. So now I have everything I need. I can go graph. The center is at -2, +4. I'm going to go 2 units in the x direction, 3 units in the y direction, and sketch my ellipse. Just like that. Okay. This time they ask us to find the foci of this ellipse. Well, to find the foci, we need to get a and b, because c squared is a squared minus b squared for an ellipse. So if we're asked to find the foci, you must find that c value. Okay? All right. I'm going to begin by grouping my x's together again. Leave a space. Group your y's together. leave a space, move the 21 to the other side, factor a 4 out of your x terms. We don't have to factor anything out of our y terms. Just like that. I add 4 inside to complete the square, but I'm really adding 16. I add 9 to complete the square on my y's. And I get 4 times x plus 2 squared plus y minus 3 squared is equal to, okay, this is 25 minus 21, so that's a 4. I divide both sides by that 4, and I get x plus 2 squared. If you like, you can put that over a 1, or you don't have to put it over 1, of course. Y minus 3 squared over 4 is equal to 1. For an ellipse in standard form, you must have a 1 over here. Okay, now that we have that, I can find my c squared. C squared is a squared minus b squared, the larger minus the smaller. So c squared is 4 minus 1, c squared is 3, so c is the square root of 3. That's the distance from the center to either focus. So the center of this ellipse is the point -2, +3. And for this ellipse, the foci lie in the y direction, because 4 is larger than 1, the foci lie in the y direction. So I add and subtract square root of 3 from my y coordinate to get the foci. Oops. So the foci will be -2, 3 plus and minus square root of 3. Okay. Another aspect of ellipses is eccentricity. Eccentricity. So one of the reasons it was difficult for early astronomers to detect that the orbits of the planets are ellipses is that the foci are relatively close to their centers. So their orbits are very nearly circular. So to measure the ovalness of an ellipse, we can use the concept of eccentricity. So the eccentricity of an ellipse is the ratio of the distance from the center to one of its foci, that's our little c, to the distance from its center to one of the major endpoints, that's a. So eccentricity is the fraction c over a. For an ellipse, c is always less than a. So for an ellipse, eccentricity is going to be between 0 and 1. If it was exactly 0, we'd be looking at a circle, because c would be 0, there would be no difference between the focus and the center. So for an ellipse, eccentricity is always bigger than 0 and less than 1. Okay? This circle, I did this on Desmos. You can see it's 3 in that direction, and it's slightly over 3 in this direction, and that's the eccentricity. This ellipse has a very different, the foci would be very far away from the center. So this ellipse has eccentricity 0.968. So the orbit of our moon has an eccentricity of this small. So think about that. Look how circular this looks. If I just showed you that, you might first glance say, that's a circle. If you look really close, you see that it's not. But that eccentricity is 0.3 something. Our moon's eccentricity is 0.05. So that's, you can see, it's very, very circular. It's just slightly an ellipse. Okay, and I looked up some of the other, some of the planets' eccentricities of their orbits. They all have elliptical orbits that are very, very close to being circular. Which has the most elongated orbit? It would be the highest one. Which one has the highest orbit? It looks like Mercury does. So it would be like the most maybe elliptical, okay? Which is the most circular? That would be the very smallest one. Here's a 0.006. Here's a 0.008. I think it's going to be Venus. Okay, let's determine the eccentricity of this ellipse. So if I'm asked for eccentricity, I know my formula for that. Eccentricity is equal to C over A. C I get from this equation. Oops, not plus, minus. Okay, if plus here, minus here. So C, I'm saying that because of hyperbolas, it's going to be the other way around. Plus here, minus here. Okay, so I just take the bigger minus the smaller. 25 minus 20. C squared will be 5. C is the square root of 5. So eccentricity is square root of 5 divided by A. This is A squared, so A is 5. The major axis of an ellipse is of length 10. The major axis of an ellipse is of length 10. That means 2A equals 10. The major axis has length 10. 2A is equal to 10. The minor axis is of length 3. That means 2A is equal to 3. Determine its eccentricity. Well, if 2A is 10, then A is 5. If 2A is, that should be a B, not another A. If 2B is 3, then B will be 3 halves. Okay? So to get C, to get the distance from a center to a focus, C squared is A squared minus B squared for an ellipse. C squared will be 25 minus 9/4. So C squared is 25 is 100/4. So this will be 91/4. And C is the square root of 91 over 2. So eccentricity is C divided by A. If I multiply top and bottom by a 2 here, I reduce this to the square root of 91 over 10. That's our eccentricity. One more thing. The area of an ellipse. We know the area of a circle is pi r squared. The area of an ellipse is pi AB. That really does make sense if you think about it, because for a circle, these are both the same. So it would be pi r squared. For the area of an ellipse, it's pi AB. Okay? So for this, for the ellipse in number 10, the area would be pi times A times B, which would be 15 pi over 2. Alrighty? Okie doke. That's it for ellipses.